Hello again. It's Paul Beckwith, and Shackleton here wants to be in the video again. So I'm continuing my discussions on marine heat waves. Um, the most notable heat wave in the ocean um, recently is the one that formed in 2014, 2015, known as the BLOB. So this formed in the off the west coast of North America, and it persisted for a long period of time and greatly affected marine life in that region, but also weather phenomena globally. So I'm just going to continue right into where I left off from the previous video. Come on, come on. Ah, persistent cat. Okay, so I showed you the features, based on I showed you the maps of the data on sea surface temperature in the previous video. So just to remind you, um, this is the present situation here. So we've got this warm water area here persisting because the jet stream there's been a ridge over there, so there's been hot air coming up from the equator and sitting over this region, heating the water. Mostly this is the anomaly at the surface, but the longer it persists there, the heat goes deeper and deeper, and has huge implications on marine life in the region. So I'm going to go to Earth Null School. So if you just Google Earth Null School, and we're looking at the ocean currents, the sea surface temperature anomaly. Okay, and what you can see is, if you click on this, 3.3 degrees Celsius, this is the anomaly relative to the climatological mean on this particular time and day in this particular region. And what you can see here is there's no sign of an El Nino. This water, in fact, is leaning towards a La Nina state, colder water than normal. Okay, over this region, although officially I believe it's still in a neutral state. But the key feature is that this water here is much, much warmer than normal. Okay, if we just look at the sea surface temperature and not the anomaly, okay, so you can see it's all red, it's all warmer than normal, but to get the actual temperatures, you can see see here the feature. So normally the water is cooler here, and up here it's hotter. So you get the colder water in this tongue here, but it's much, much warmer than normal, as you can see from the anomalies. And if you look at the jet stream pattern right now, so looking at air now, 250 millibar height, the wind, there's a little bit of a dip here, and there's a little bit of a ridge here, a very broad ridge. So it's underneath this region here that we're getting this blob feature, this very, very warm temperature anomaly. So let's have a look at Twitter and see what people are talking about in terms of this anomaly, and also some of the other key things that have happened recently, a synopsis of some of the key things. Of course, Greta Thunberg's speech, a really big deal. I really encourage you to watch it. I'll probably do a separate video on methane underneath the Antarctic. We're concerned in the Arctic of the methane on the eastern Siberian Arctic shelf. As the water warms and the permafrost barrier is thawed, the methane can come up. And of course, to give you an idea of the methane that's under the Antarctic ice, a recent paper came out and it's saying that between 80 and 480 gigatons of methane is under the Antarctic ice. Antarctic ice. Come on, these cats are really distracting me. Sorry. For context, cattle and other domestic animals around the planet produce about 0.08 gigatons of methane per year. 80 gigatons is 1,000 times that amount. So even if we're at the low end of methane under Antarctic ice, it completely and utterly dwarfs by 3 orders of magnitude the global annual emissions of methane from domestic animals around the world, just to put it in context. Huge amounts. This report here just came out today. I haven't had a look at it yet. The IPCC special report on the ocean and cryosphere. So I'll read it over the next few days, and I'll be doing a whole bunch of videos on this, I am sure. Okay? Critiquing it, seeing what they're including, what they're not including, etc. It's publicly accessible. You can just go and have a look at it. Is the blob back? Not like it was in 2015, but it's heading in that direction. Okay, here's August 2014, August 2015. Here we are in August 2019. Okay, so we're seeing signs, like I said, that it's coming back, and people are starting to communicate that information. Lots of other neat stuff here. I talked recently about the sudden stratospheric warming in the southern hemisphere, the warming up at high, and the splitting of the polar vortex, and the implications that will have to, I gotta give the cat some food, climate and weather in Australia, Patagonia, and New Zealand. Okay, so here we go. Here's an image from September 2014 of the blob, and here's where we are in September 2019. Again, the warming, significant warming here off the U.S., and then sort of an annular ring of warming with a bit less warming in the center. This is where we're at right now. This is from a Spanish article, so I put it into Google Translate, and it's not perfect translation, but it basically talks about the blob, and causes not necessarily known. I mean, it's climate change, and the effect on species. For example, the population of humpback whales declined 30%, Pacific cod, 100,000 fish, birds, deaths reached 500,000. Sea lions, salmon, crustaceans were all affected. Toxic algae appeared, which had horrendous effects on a lot of the animals. The temperature was raised 4 to 5 degrees Celsius above normal in parts of the ocean. And there's a similarity between what's happening now and what happened then. So we're keeping a close eye on it. This is a Washington Post article, which I highly recommend, talking about dangerous new hot zones spreading around the world. It talks about the hot zones on the land, but it also talks about marine heat waves and hot zones. And the focus in this article is on this hotspot region just off the east coast of South America. Okay, so highly recommended. And it does talk a lot about marine heat waves, but by focusing on this particular region off South America. But I'm just putting it up there to recommend it to everybody. This is an article on how, this is a published peer review article on how there's an intensification and poleward shift of subtropical western boundary currents as the climate is warming. Okay, so I look at the figures, and you can see these areas here where there's exceptional warming, and it's on the western side of the ocean basin. So on the eastern coasts of continents and land masses, and the western side of the oceans. Okay, how the heat is increasing in these regions. This is showing you basically the sea surface temperature indices. So there's basically the trend is up, and they look at specific currents. This is the Kuryoshi current off Japan. This is the Gulf Stream, the purple. This is the Agulhas current. This is the Eastern Australian current is the red, and the Brazil current. So these are all the western boundary currents and how the temperature is increasing on these currents. And again, there's lots of maps showing the distribution of heat. And if you go down to the conclusions, okay, if you go down to the conclusions, basically there's an intensification and poleward movement of these western boundary currents in response to anthropogenic climate change. Okay. The one exception is the Gulf Stream, where a weakening of the AMOC is reducing the strength of the Gulf Stream. But all of the other currents are intensifying and moving to the pole, and you can contribute a lot of that to the Hadley cell enlarging and also moving to the pole. This is another paper on the enhanced warming of these boundary currents, and I'd like to point out it's saying that we find that the post-1900 surface ocean warming rate over the path of these western boundary currents is 2 to 3 times faster than the global mean surface ocean warming rate. So this is a key factor that, you know, warming is very non-uniformly distributed on the planet. We know that the Arctic is warming 2 or 3 times faster than the rest of the planet. We know that the high Arctic is warming more like 4 to 5 times faster than the planet. We know that high alpine regions, mountainous regions, are warming at least 2 to 3 times faster than the global average temperature. We know that land masses, if you on the land, the warming is 2 to 3 times faster than the global warming, globally average warming. And now we know that the sea surface temperature, the warming of the oceans, is 2 to 3 times faster on the western boundary currents than it is than the overall ocean warming. So we're getting all of these asymmetric warming situations, which are very, very, crucial. We mostly talk about global average temperatures, but there's a lot of distribution of temperatures. And this is why, for example, different regions are being affected hugely different amounts by abrupt climate change and extreme weather events. Okay, this is an article here which is all about the record marine heat wave in the southwestern Atlantic shelf. So this is all talking about the heat wave off South America. Okay, basically sea surface temperature, days with marine heat waves per year, in this particular region. And you can see, very few days where it was very hot in this region, 2014, 2015, 2017. Huge uptick in this heat wave here. And you can see a spike here occurring. This is in 2017 here, okay? The red dot here. Basically this region here. Okay, so to get more information from Twitter on this, I tried looking at the hashtag BLOB, and unfortunately wasn't very successful to find information on the marine heat wave. So I went to oceans, and you can get lots of information. Here's some more stuff on the recent marine climate report. And there's lots of stuff on the marine heat waves, and global warming is causing an ocean emergency. Okay, so I went further and I, just Googled NOAA BLOB 2019, and there are articles starting to come out on it. I'll just give you a flavor of them. New marine heat waves emerges off West Coast, resembles the blob. With this image that I've shown you already. And California currents, all kinds of information here. Very good government website, the Integrated Ecosystem Assessment site on the California current. Lots of good information, detailed technical information there. And more images. This is the marine heat wave, the areas of feature, so lots of them, here in so-called blob. And there's loads of other information. Is the blob back? So thank you for listening.